Okay guys, this is Ms. Ellison. Today is Thursday, April 2nd, and I wanted to give you guys just a little bit of a face-to-face view on what to do with linear versus exponential functions. We're going to go through this. We did it in class right before the weird break that we're having, but I wanted to touch on it again. So when talking about linear versus exponential functions, we have these two functions rules here. And at first glance, they seem pretty reasonable. You can notice that this 2x plus 3 looks very similar to what we were doing with the y equals mx plus b. That's because it is, in fact, linear. So we're going to go ahead and take this blue marker just to help make it stand out a little bit, that linear function is, in fact, the 2x plus 3. This other one then kind of leads it to obviously being exponential. If the big kicker here, if it has an x as the exponent, it is exponential. So this 1/2 times 2 to the x is our exponential function, all right? So linear versus exponential, just looking at the functions themselves, we can see what they have different, right? In the linear function, the x is going to be multiplied by the factor of 2, okay? This is, if you remember, what is this called? The slope, right? And then we add to that a starting point, okay? Over here in the exponential function, we have our x for the exponent. It's kind of hanging out here on top. It's being multiplied by a 2 as well, just like in the linear function. But when we are taking this 2, this isn't being multiplied by it. This just seems to be hanging out here with the parentheses. We think multiplication, not quite. Remember, the rules of exponents tell us that when we have a variable on the outside, or an exponent for that matter, on the outside of parentheses, we distribute that exponent in to the base. So this is going to be 2 to the power of x, and that helps us know it's exponential. This over here, this 2, we knew as the slope or the rate of change. This 2 here is kind of similar. This 2 in the exponential function, do you guys remember what that's called? It's the common factor or the common multiplier, right? It's what it's going to change by, but it changes in the form of a ratio, right? We're going to multiply it by 2 every single time instead of just adding 2 every time. The part that gets confusing is that we see this as multiplication, so we think, oh, this is multiplication. It's not in the sense of when we are adding to a linear function, it's what are we adding each time. Remember, repeated addition is multiplication. Repeated multiplication is exponential powers, all right? So that's where it can get a little tricky. Now, what about this guy? Okay, we know this is like the y-intercept, the starting point, right? It's the same thing here. This 1/2 is what we call the starting amount. So it's the same idea. It's when x equals 0. Okay, so when x equals 0, y equals whatever that is. Okay, so let's go ahead and get these into our tables and see what we can do with them. If we have our input, our independent variable, x equals -1, all right, so then our output, well, we plug in -1 here. And so let's get some math going here. Grab my eraser. If we have 2 times -1 plus 3, 2 times -1, -2 plus 3. -2 plus 3 we know is what? -2 plus 3 is +1. 0, plug a 0 in. 2 times 0 plus 3. I'll put the answer out to the side here. This is 0 plus 3 is 3. Plug in a 1 for our x value. 1, 2 times 1 is 2, plus 3 is 5. 2 times, plug in a 2 for our x value, is 4, plus 3 equals 7. So far with me? what are we noticing? What is this growing by each time? We can tell that it's growing by 2. There's that 2 right there, okay? So we know that the next one, because the change is constant, we know the next one, 3, 5, 7, 9, and 11. Okay, that is our linear function. So we're gonna graph that. We'll go ahead and graph it in the blue or purpley color that we started with. So we have -1, 1, our x and our y. So over here, our x is -1, and we're gonna go up 1. Our x is 0, we're gonna go 3. X is 0, we're up 3. We've got a good slope going there. We have x is 1, y is 5. X is 1, there's 3, 4, 5 for x is 1. X is 2, we have 7. It's going to go up 2 from there. X is 3, 9, 2 from there. And without even going back to my table, I should be able to know and infer, right? If it's going 1, 3, 5, 7, 9, the next one's going to be 11. So at 4, we go up 2 more, and luckily my board hits right at 11. We're going to count these just for 1 unit each, okay? All right, so if this is my line, I can do my best to draw this nice straight line here. That's not bad. That's not bad. We could do better maybe. Okay, we'll fill that in. All right, so we have our lines, our line, our arrows. It's going to continue. All right, let's look at our exponential function. This one's a little trickier with the math. I'll run through it with you. -1 is in for x. So if we have 1/2 times 2 to the -1. Remember what happens when we multiply or take up something to the power of -1. Remember what happens? What do we do with that negative exponent? Remember, we drop it like it's hot. So we have 1 over 2 to the first. Well, what's 2 to the first? Just 2, right? So we have this, but then we have this down here. We have 1/2 of this 1/2. Well, that seems kind of strange to multiply the fractions. Think about what's half of a half. You get 1/4, right? Okay, or you could think of it as 1 times 1 is 1, 2 times 2 is 4. So for our first problem here, when x is -1, y is going to be 1/4, or f of x, right, our output. When we plug a 0 in, let's go ahead and take this, and we get 2 to the 0. Remember, this is times 1/2, okay? So 2 to the 0, we know anything to the 0 power is 1, so this is going to be 1. Well, what's 1/2 of 1? 1/2. And you guys might be able to see what's happening so far. All right, let's change it up. We have 2 to the first. Well, anything to the first power is itself. What's 1/2 of 2? 1. And we have 2. Let me get that. 2 squared is 4. What's 1/2 of 4? 2. Do you guys see what's happening? What's happening each time? All right, those of you who have it, go ahead and complete it. Those of you who are still kind of wondering what's going on, stick with me. We're going to have a new exponent. X is now 3, so we're going to have 2 to the third. Okay, 2 to the third is not 2 times 3. It's not 6. We have 2 times 2 is 4, times 2 is 8. So right here we have 8. 1/2 of 8 is 4. Okay, and then, whoops, not this one, this one. This is our x value, right? Our x is in the exponent, so it's exponential. 2 to the fourth. We got 2 times 2 times 2 is 8, times 2 more, so we have 4 of them, right? 4 2s would not be 8, it's 16. What's 1/2 of 16? 8. Okay, so let's graph this. We're gonna be a little bit tricky in here. We've got to get to 1/4. We'll do our best. -1 and 1/4. Let's see. -1 and 1/4. Here's about half, so maybe like there. 0 and 1/2 is here. That's not too bad. 1 and 1, okay? That's gonna be about there. 2 and 2. 2 and 2. Now be careful, don't get caught up with this pattern that you're seeing and think, oh, the next is 3 and 3, right? It's not, it's 3 and 4. What's happening here each time? Well, remember over here we were adding 2 for the linear. What are we doing here? We are multiplying by 2, okay? Multiplying by 2 is for exponential, that repeated multiplication. So we got 3, 4, 3, 1, 2, 3, 4, and 3. It's about here. And then 4 and 8. So let me get over here. 4, oh, I'm gonna fix that one. I went too far. So there, and then 4. So here's 4, 5, 6, 7, 8. Which makes sense because, oh, I went too, well, that's why I got this one off, guys. This is 1, 2, 3, 4, 5, 6, 7. Oh, I need to go up one more. 8. There we go. Okay, so let's see if I can get this a decent. And it gets really steep right there, huh? Okay, so look, when we're doing this, I'm not looking at perfection, okay? I want to see a couple things. I want to see that you know it's not crossing the x-axis, okay? And I also want to see where it's crossing the y-axis. Because what's important about that point? Did you guys notice that? Look at this 1/2, this 1/2, 1/2, right there. Just like this 3 and this 3 right here. Let me rewrite that. Okay? So this 3 this 3 right here. Those are the starting points, right? That's when we know that the graph is crossing the y-axis when x is 0, okay? So when I have that starting point, I can say, okay, well, this is where it started. I know that at that point it's going to cross my y-axis, and then I can graph from there. Okay, pick up my pin cap. I'll let you guys look at that for a sec. Do you guys recognize everything going on? We recognize the starting points on our graphs, or where they cross the y-axis. 3 and 1/2. This is x is 0 and 3. This is x is 0 and y is 1/2. Okay? So when we write our functions, I'm going to put this down a little for you guys to see. Okay, so linear functions versus exponential. We know that a linear function is, well, that's an equation, right? I'll do a function, f of x. F of x equals mx plus b. Right, this is what we know, this is what we've been doing, this is what we're good at. This is the slope. This is, you guys remember? Yeah, we just did it. Look up on the board, see where it is. What is that piece? This 3, what is it? It's our y-intercept. Right, the y-intercept, okay? So then for our other piece, for our exponential function, we have f of x equals, do you guys remember what this one is? We did it just before the break. It's a times something to the x. You guys remember what that letter is in there? B. Okay? AB. I guess if we had another letter, it would be C. We don't need to worry about it. Okay, so remember, this is our y-intercept. It's different. It is not this B, okay? They are different in that this is a B, well then that should be the y-intercept. It's not, all right? This guy in here, guys remember this one, what that one is? What happened? What was the 2? Where did we find that 2 again? Remember? Remember? Maybe this would help. Remember what happened? It was adding 2 each time, okay? Because multiplication is repeated addition, all right? And what was happening over here? We were multiplying by 2 each time, okay? This is exponents is repeated multiplication. So this right here isn't the slope. Remember, it's the common multiplier or constant factor. Okay? Sometimes they do different combinations of these two words. They'll say common factor, they'll say constant multiplier. Any combination of the two is just fine, all right? The idea is that we're multiplying something again and again and again. And that's what causes that really sharp increase, right? How we started off low, whoa, sorry. We started off low, right? And it grows really fast. Obviously, at first it looked like, oh, when is it ever gonna get there? Okay, if you've done your decimals activity, the Avi and Benita, it seems like one way pays a lot more money, right? Because they're paying like, what was it, $100 a day. And the other one's like just a couple cents, a dime, right? But after time, it builds up really fast. So as you're going through your paper and it's asking things like on the back, the notice and wonder, when it's asking to look at the equations and make predictions, okay? I want you guys taking the time to make those predictions. Play around on that link in the decimals. Play around on it, okay? And you can make the predictions of what's gonna happen in those, and then down underneath on these problems here, think about what's that y-intercept, right? Is it going to increase or decrease? All those things, okay? It's okay to be wrong. This is when we're exploring. Okay, so I think that's it for today. Just talk about how we notice things are different. Really get this cemented in your mind. Try to really focus on what's going on here and how we can start understanding when we look at something. Is it linear? Is it exponential? Because sometimes they seem the same depending on the inputs and then outputs, all right? All right, these videos, they're gonna be different, various lengths. Stick with me. If you need part of it, watch it, obviously, right? Take notes. These can be notes in your journals. If you don't need part of it, skip it, okay? It's what you need. Rewatch it if you need it. Go to the part where it looks like I'm talking about something that you need. This one is gonna be about 19 minutes and some change, which is quite a long time, but hopefully there's some good information for you. So, miss you guys. Hope you guys are having a good time, and let me know what other videos you guys want to see. All right, take care.